Got to give the people, get the people what they want. All right, we're going to solve some log equations. This one is not a lot to write down. I think you're just going to learn it from doing it and trying it. You all have all the tools that you need. So 3.4, solving log equations. All right, so to solve log equations, you must use all of the properties that we have learned and all of the algebraic manipulation you know to isolate the variable. It's just solving equations, all right? So let's see what we can do with this. Man, let me move this down. I'm tripping in these streets. Let's see. All right. So go ahead and write down example 1, log base 4x minus log base 4 8 equals 0. For this one, as soon as you see two things equal to 0, that means, you know, they and you see log base 4, oh, don't want that. And you see log base 4, right? So these two things have the same base. You subtract them from each other and they equal 0. That means that this and this have to be the same, right? Because it makes sense that log base 4 8 minus log base 4 8 would have to equal 0 because it's the same thing minus itself. All right, so right away, if you start seeing, oh, two things and they're being subtracted and they equal 0, you're probably going to guess that the piece that's unknown is equal to the corresponding piece that is unknown. So in this case, x equals 8. It just is what it is. Recognize that when you see stuff equal to 0. All right, go ahead and write down number 2. It says 1/3 to the x equals 9. All right, so there's actually a ton of different ways you can solve this. If I was going to solve this, though, I'm thinking, all right, well, I know 1/3 is the same as, what is that? 3 to the negative 1 power. So that becomes 3 to the negative 1 times x. So 3 to the negative 1x. And that equals, well, 9. But I'm thinking, ooh, 9, that's like 3 squared. So now, once I have the base and the base that are the same, that means that negative 1 times x has to be the same as 2, right? They have to end up being the same. So, divide by negative 1, divide by negative 1, x equals negative 2. Boom, bam, bow. All right, let's keep it moving. Write down number 3 for me, please. And why don't you try to solve number 3 on your own? I bet you can try to solve that without me. How are you going to get x by itself? Cool. Check what you did and see if it agrees with what I did. So I'm thinking here, and I'm going, okay, well, I have log base 10 of x to the equals negative 1. Well, how do I get rid of log base 10? I take it to the 10th power. So 10 log base 10 cancels out, and I end up with x. Well, I have to take this negative 1 up to, it's not even to the 10th power. I don't actually know how you say that. I forget the word. Exponentiate. I have to exponentiate it. Ooh, I found it in a book. I'm smart. All right, so x equals 10 to the negative 1 power, which means that x equals, what's 10 to the negative 1 power? 1/10. Boom, boom. All right, go ahead and write down number 4. Isolate the x and then start doing what you got to do to solve it. Cool, you did that. I'm like, all right. So I see this and I'm like, okay, I need to get this part on its own first. So I'm going to divide by 3. So I end up with 2 to the x equals whatever 42 divided by 3 is. I don't know what that is. Calculator, help me out. 42 divided by 3, 14. Okay? 2 to the x equals 14. So now, okay, well, how do I get x alone? What's that word? Exponentiate. No, I don't even have to exponentiate. Dang. I have a base of 2, so the way I get rid of a base 2 is I go the log base 2. Yak, yak. I'm left with x. And now this is the log base 2 of 14 as well. All right, so now I'm at x equals log base 2 of 14, and I can actually solve that, right? So to figure out what that is, I know that x equals, this is now change of base. Change of base, right? So I can do, okay, so that's just the log of 14 over the log of 2. And I'm going to do that in my calculator. You're going to do it in your calculator as well. Y'all all have calculators on your phone that have these scientific buttons. Get her done. Let's see. Log 14, boom, divided by log of 2. I end up with 3.807. 3.807. Did you end up with the same thing? All right. Well, we'll see. And let me just double check. Let me make sure I'm right. Left, right hand, left hand. Boom. We are looking good. All right. Let us do number 5. Why don't you now write down number 5 and try to solve number 5? Start to try to get ahead of me on this. I think you all got this. Use regular algebra stuff until you get that like exponent, that x and the exponent by itself, and then start using all your tricks. All right, cool. So you were like, okay, I paused there. I'm like, all right, let me get rid of this minus 3. I'm going to do plus 3. Okay, so 4 times e to the 2x equals 2 plus 3, which is 5. All right, I got to get rid of this 4. This is just basic algebra. Let me divide by 4. E to the 2x equals 5 over 4. All right, I'm looking pretty good right now. I'm in good shape. But now I got to get 2x on its own. And how do I get rid of base e? I take the ln base e. Yak, cancel. 2x equals ln base e, if you want, of 5/4. All right? Woo! Okay, so at this point, I'm going to be like, all right, well, how do I get rid of this 2? Divide by 2. Divide by 2. X equals ln 5/4. Remember, we don't really have to write the e, over 2. All right, now we just got calculator work. So let's see, yak. Let's do the ln 5 divided by 4. That is that number. And I'm going to take that and divide it by 2. And I get 0.1115. X equals 0.1115. Boom, boom, boom. Should we do more? Yeah, we should.